Hello students, today we'll discuss IB Math SL Paper 2, May 2019, Time Zone 1. In this paper you can use graphing calculator TI 8420+, for example. My name is Nariman Merlim, I'm located in Baku. Here you can see my mobile and email. So to prepare for exam you can use textbook of Oxford 2012, look through guide, Mathematic SL guide. But for sure you should have Mathematic SL formula booklet for use during the course and in the examination. So this formula booklet will be available for you during exam. So this is the cover page. Now we come to the section A, first question. Ten students were asked for the distance in kilometers for their home to school. Their responses are recorded. For this data, find the mean distance from a student's home to school. So in this paper I found that it's better to avoid using calculator. Then you can get easy solutions. With calculator you have long time-wasting calculations, but I will show you both solutions. So here, to find mean, we should add all these values, 10 values, and divide by 10. We will get 4.82. But also you can use calculator. To use calculator, you should follow these steps. Start, edit 1, insert data, start, calculate 1, enter. Let's do it. So we press start, edit 1 is chosen, so we press just enter, and we should copy these values into the first column. So 0.3, 1, 0.4, second value, then 2 times 3, 3, then 3, then 3.5, then 5, 7, 8, 8, and finally 10. Now we press start, we go to calculate and we choose first line. So list is L1, frequency list we don't have, calculate. And we get mean value 482 as before. So this question is done using calculator. Next question. The following boss and whisker plot represents this data. Find the value of p. First of all, from the book, page 269, we see that this is minimum value, this is maximum value, this is first quartile, this is third quartile, and this is median. So we should find median. First, try to find it with method 1 without calculator. Median is at n plus 1 over 2's position. N is number of entries. So we have 10 entries. 10 plus 1, 11, by 2 is 5.5. So we put our values in the increasing order. And between 5th and 6th position, there is no element, so we should find average of 5th and 6th position. So we add these two values, divide by 2, and we get 4.25. This is median, so this is P. Method 2 is with graphing calculator. So we press var. Here we choose statistics 5. We go to PTS, we press PTS and we choose in PTS median 8. So PTS, then 8. And we get the same value, 425. To get interquartile range, we find difference between Q1 and Q3, and it is 5. So this question is done. Next question. Consider the graph of function, quadratic function. Write down the coordinate of vertex. Method 1. So if we compare our function with ax squared, we see that our function is, for our function we move 15 units up and 10 units to the left. As a result, the vertex at 0, 0 moves to this position. Second method is with calculator. So first we press y equals. We choose, for example, a equals 1 for simplicity. Then we get x plus 10 squared, x plus 10 bracket closed squared plus 15. And we press draw. So we see that it is trying to draw. Now it's finished, but we don't see the graph. So we go to zoom and we choose zoom out, number 3. And again we press enter. So it's trying to draw again with another scale, and now we see the parabola. To find vertex, we go to second trace, we choose minimum 3, and we should show left boundary and right boundary. So left boundary somewhere here. We press enter. Then we go to the right boundary. We press enter. We press enter again, and after some guess, we get minus 10 and 15. The same value, minus 10 and 15. The graph of f has y-intercept at minus 20. Find a. So y-intercept means that x equals 0. So x equals 0, value of function is minus 20. In this case we can find a. Now we know a, and point P with coordinate 8b lies on the graph. So now we have the whole function, and we should insert the coordinates of x equal 8, and we should find b. So we substitute x equal 8 and we find b. So this question is done. Exercise 3. Question 3. Consider the function. So function is product. Find first derivative. So because it is product, we are using product rule, and because some functions are composite function, we are using chain rule. So first derivative will be derivative. So derivative of product is given by this formula. So u here is x squared, v is here to the 3x. So first derivative of x squared is 2x multiplied by e 3x plus x squared. Derivative of e3x is e3x and derivative of 3x. So this is the answer. The graph of f has a horizontal tangent at x equals 0 and x equals a. Find a. Horizontal tangent means that derivative equals 0. Method 1. Fast and easy without calculator. So we substitute for our expression of derivative the value of a, x equals a. Then we divide both sides by e3a and we get very simple answer. Method 2 is complicated with GDC. Let us do it. Right, okay, so we go to y, we clear, and now we should insert our function. It is 2x second e raised to 3x to the right plus 3x x squared second e raised to 3x. So let us go to the right, let us check. So 2x e to the 3x plus 3x squared e 3x. Because we used before zoom out, now we go to zoom and we choose standard 6. So we are drawing with standard zoom. It will take a lot of time before it draws the picture. To avoid this, we'd better show in window that so we have something. Yeah, we already have a picture, so we need 0 somewhere here. Didn't finish still. Working. Stop working. Now we go to Windows, and for x maximum we put 0. To have better picture, because y is about 0, we'll choose 0.1 minus, and here 0.1 plus. Then we'll have very nice picture. But what I like most that we limited x to 0, so it will take less time to draw. Still takes time. What we see that solution is between 0 and -1. So we go trace 0, left boundary we put -1, -1, enter, and right boundary we put, for example, minus 0.1, for example. Press enter. Yes. Right, so minus, okay. We can try to convert it into the fraction right from here. So we press alpha, then and we choose 4. Unfortunately, it doesn't work, so then we go to clear. Let's check that we got our answer. This is our answer. Now we go to alpha 4 and we get, yes, only now we finished with working with graphing calculator. We finished with question 3. Now question 4. Let second derivative be cosine sine from x from 0 to 1. A. Sketch the graph of f second derivative on the grid below. So what we do, we go to y equals. Here we should insert our function cosine 2x bracket closed sine 6x bracket closed. So windows x minimum from 0, x maximum 1. And draw. Let us increase windows. Let's make windows for. I think that something is wrong with the function. Let's check the function. Oh, it is okay. Okay, so let's check the function. So we first check function cosine 2x sine 6x. Right. Windows, let's make minimum -1, maximum 1, and draw again. Why 1, 1? Because cosine maximum 1, sine maximum 1, and minimum -1. Right. So when you finish, so you can sketch this graph, but for sure you need important points. So this is 0, 0 for sure. You need maximum. You need intersection. minimum and maximum, second maximum. Let's find, for example, first maximum, okay, second trace maximum. So we move to the right. We can actually put 0, and we can move from 0. Enter. Yes. So we have x equals 0.233, 34 when we have first maximum. You can do this also without calculator. Cosine 2x equals 0. Cosine, okay, actually you can do it with calculator. So find all these points and there will be no problem. So next question. Find x coordinate of the point of inflection of f. Inflection point is where second derivative is 0 and second derivative change sign. So we need to find actually this 0 and this 0. So let's find them. So second trace 0. First 0. So we go to left boundary of first 0. Enough. Enter. We marked left boundary. Now we go to the right of the 0. We mark right boundary. Guess. And we get a 0.524, so we copied 3 significant figures. This is 1 point, and second point, again second trace 0. Now we show left and right boundary of the second 0 point. Enough. Press enter. So we marked left boundary. Now we go to the right. We marked right boundary. Yes, and second 0. 0785. Right, so we have these 2 zeros, and this is the point of inflection. Both are points of inflection. Why? Because at each point second derivative changes sign. Next question is hence find the values of x for which the graph is concave down. Concave down, second derivative should be negative. It is negative between these two zeros, so we show this interval as answer to C. So this question is done. Next question. A jigsaw puzzle consists of many differently shaped pieces that fit together to form a picture. Jig is doing a 1000-piece jigsaw puzzle. She started by sorting the edges pieces from the interior pieces, edge places from the interior pieces. 6 times she stopped and counted how many of each type she had found. The following table indicates this information: edge pieces and interior pieces. Jill models the relationship between these variables using the regression y equals ax plus b. Write down the values of a and b. So first of all, we use calculator, and we follow the following. So start, edit, type in data, start, calculate, 4, enter. So let's do it. Start, edit 1, and as you see, I have already inserted for first column x values and for the second column y values. Again, start, calculate, and we need line 4, linear regression ax plus b. Line 4, so we choose 4. So x list is L1, y list is L2, frequency list we don't have, store regression equation we don't have, we calculate. So we go down to calculate and we press calculate. And this is our values: 693 and 881. So we found these values. Use the model to predict how many edge pieces she had found when she had sorted a total of 770 pieces. So we convert this into the following information. Total 750 pieces, it means that y plus x equals 750. On the other hand, we have y equals ax plus b, this relation that we found here. We rewrite it for y, so we move 693 to the left with minus, and as a result we have system. Let's solve this system. How we're going to do it? Using applications. We go to polynomial simultaneous, add advertisement, simultaneous equations is second, so we choose second. Number of equations 2, number of unknowns 2, and we go to next. Right, so now we put the numbers y equals, so 1 750, 1 750 first equation, 1 minus 1 8, not minus 1, sorry, minus 6.93, minus 6.93, enter, and 883. 883. Let's check that we inserted everything correctly. So 750, 1 minus 693, probably. Yes, minus 693 and 883. Let's go to solve. We should turn it into, okay, so y equals 656 and x equals 93, so 93 is our answer. Finish this equation and finish this question. Question 7. Consider the expansion of nth power. Given that coefficient of the term x6 is greater than 200,000, find the smallest possible value of n. So from section 1.3 of booklet, we know that binomial coefficient is given by this formula. Binomial theorem looks like this. Let us rewrite our binomial and change order. 1.2 plus x squared. Corresponding term that we need will be like this, and 2r should be equals to 6, so r equals 3. So it is coefficient term, this term, and hence coefficient is this coefficient. Method 1. We write the coefficient, simplify, and now we have the following. So we can insert this function and check where it is less than 200,000. So x minimum will be, n will be, so x is n. So x minimum will be 3, x maximum, for example, 100, y minimum 2, and y maximum 250,000. Let's check. So first of all, we clear everything. Second, quit. Y equals, clear. Now our function. X times, without times, x minus 1, x minus 2, times 2 raised to 2 raised x minus, not 2, 1.2, sorry, 1.2 raised to x minus 3 and this divided by 6. Divided by 6. So done. Why it's raised? I don't understand. Delete. Delete. Divided by 6. Right, then Windows, x minimum is 3, x maximum we don't know, we assume 100, y minimum 0 and y maximum, for example, 25,000. Plus we need another function which is 200,000. By the way, Windows we put 250,000, so we need to add here one more zero. And let us do it. So this is our sequence in terms of x, and finally it should draw a line 200,000. Here is the line. So we will need to find intersection when this happens. Right, second trace intersection 5. First curve, second curve, guess, intersection happens when x equals 26 and so minimum when this happens, because x should be a whole number, we round it to 27. So answer is 27. For advanced users you can change mode to sequence, write the following expression, and then look not to the graph but into the table, scroll and find when this expression is greater than 200,000, and you will find that this happens at 27. Finished with this question. Question 7. Right, the first terms of an infinite geometric sequence UN are 2, 6, 18. The first term of second infinite geometric are 2, minus 6, 18, minus 4. The terms on third sequence W are defined as sum of the terms. A. Write down the first three non-zero terms of W. So it will be for n equal 1, 3, and 5. The rest will be 0, second will be 0, and fourth will be 0. And here are answers: 4, 36, and 236. The finite series W can be rewritten in this form. Find the value of R and M. So if we add elements of the third sequence, it can be rewritten this form. So let us rewrite. So if we add 5 terms, we can rewrite it as sum from k to 1 to 5. We can write k 0 to 2, but here we should take 4 and here 9 to the k. using this previous result, we can add 6 terms from 1 to 5. Converted, we add 3 terms from k to 2. Here instead of 5 we have 225. Then from k 0 to 112, and this is how we rewrite it. So we used analogy from less value, not 225, but from 1 to 5. So we found R and we found M, both. So I and double I. This finished question 7, and now we go to section B, question 8. Section B, question 8. Let f(x) equals 2 sine 3x plus 4 for real values. A. The range of f is between k and m. Find k and m. So we write the function. Sine has maximum 1, so we have maximum of f will be 2 times 1 plus 4, 6, and minimum will be minus 1. 2 sine 2 minus 1 minus 2 plus 4, 2. So function will be between 2 and 6. Let g equals 5 times f over 2x. B. Find the range of g. So B. So so to get g, we have scale factor 5. It means that range of g will be 5 times range of f. So 5 times 2, 10, till 5 times 6, 30. From 10 to 30. The function g can be written in the form 10bx plus c. Find the value of b and c. Find the period of g. So we write function 5 times 2x. So 2x here we'll get 6x. So we get 10 6x plus 20. Comparing algebraic form with numbers, we realize that b is 6 and c is 20. From I, the gx equals 10 sine 6x plus 20. Period of sine function is 2 pi. It means that 6 times period equals 2 pi. So period equals pi over 3. So this question is done. The equation g equals 12 has 2 solutions for x between pi and 4 pi over 3. Find both solutions. So we use calculator. We use calculator. So we press Y. The first function will be 10 y. First function will be 10 sine 6x bracket close plus 20. Second function is 12, so we put here just 12, not 22 but 12. And then we go to Windows, and here we put from pi to 4 pi over 3, and y because the left function is from 10 to 30, here we put 10, and here y maximum we put 30. Then we should get very nice picture of two graphs and find their intersections. Because we use range of function g, you see that our graph fits very nicely into window. And second function 12. So we need to find intersection, one intersection and second intersection. So we go second, trace, intersection is 5. So we move closer to our first intersection. This is first curve. Second curve, guess, and finally the answer. 382. So we copy 382 radians. Now we need second intersection. 5 again. Now we move closer to the second intersection. Second curve, this, and finally second answer, 4.03 radians. So we copy these solutions. So this question is done. Question 9. Question 9. Let f equal 60 over x. The line L is tangent to the graph of f at x equals 8. Find the gradient of L. Gradient of f at x equals 8 equals first derivative at this point. Section 6.2 derivative of xn is given by this formula. So n x n minus 1. We rewrite our function in exponential form with negative exponent, so it is 16x minus 1. So to find derivative n equals minus 1, so minus 1 minus 1 minus 1 minus 2 minus 16 over x squared. And value of this derivative at x equals 8 will be minus 0.25. It means the gradient of L at this point is minus 0.25. L can be expressed in the form, vector form. Find u. So u is direction. If this is a tangent line, the direction can be shown for the line going through origin. So B. So R equals m position vector and u is direction vector. Line L equals mx plus c, so our tangent line is minus 0.25x plus c. Vector u with gradient minus 0.25 is given by this line, so if we take for example x1, then u will be, no, x4, u will be minus 1. So we have one vector, 4 minus 1, and this vector is parallel to our tangent line because they have the same gradient. The direction of vector y equals x is 1, 1. Find the acute angle between y equals x and L. So sections 4.2, scalar product is given by magnitude by magnitude multiplied by cosine. Scalar product on the other side is product of corresponding components added. So for our case we have two vectors. First we find scalar product. It is 1 times 4, 1 minus 1 added, which give us 3. Then magnitude of each vector is given by corresponding formula 0.2, 0.17, and cosine will be scalar product divided by magnitudes. Then we have angle equals inverse function of cosine, and we get, so inverse function, I think we need so for example we need to find cosine. So we need to find second trace, no, this is not second trace, clear, second trace. You see cosine minus 1, so we need 3 divided by second square root of 34. We close bracket, so we press enter, and we get 103 radians. So this question is done. Okay, D. So let's go to D. Find composite FF. So composite FF will be 16 over F or 16 over 60 over F, which is X. Hence write down F minus 1. So F minus 1, so we write function, we solve Y and X, rewrite, and we get again the same function. Hence or otherwise, find the obtuse angle formed by the tangent line at F at X equals 8 and tangent line at F equals 2. So tangent line at X equals 8 we already found, but let's do it again. So it is gradient equals derivative at this point. Parallel vector will be along the line with the same gradient. So vector, for example, x equals 4, u equals minus 1, or y equals minus 1. Tangent line at x equals 2, the same way we get v equals minus 4x. So if x equals 1, y equals minus 4. So we have two vectors, and we should find obtuse angle formed. So we follow exactly the same procedure as before, and we find angle 1.8 radian, which is acute angle. This is why we subtract from pi 1.8 when we get 2.06 radians. So this question is done. Now last question, question 10. Very difficult question. Probability. Let's do it accurately, slowly, right. There are 3 six-sided dice. Each die has 2 green faces, 2 yellow faces, and 2 red faces. All 3 dice are rolled. AI. Find the probability of rolling exactly 1 red face. Probability of a red face will be number of red faces by number of all events possible, so 2 over 6, 1 over 3. If we are throwing 3 dice, we are having binomial distribution, and probability, binomial distribution with 3 trials, probability of red 1 over 3, probability of not red 2 over 3. So we have binomial distribution, and probability of exactly 1 red will be given by binomial coefficient, probability of success to the first power, probability of failure in power 3 minus 1. So we can calculate it and get 4 over 9. We can do the same using a calculator. So for this we need to press second distribution. Here we scroll to binomial probability distribution function, we press enter. Number of trials we have 3. Number of success is 1 divided by 3. Exactly one red is 1. Paste. To turn this into fraction form, we press alpha, y equals, choose 4, and press enter. 4, 9. So we got the same answer. This question is done. Find the probability of rolling 2 or more red faces. Probability of 2 or more red faces, so x equals 2 or 3, equals 1 minus probability of less than 1 face is red. And using calculator, let's go to calculator. So again, second distribution. This time we need cumulative CDF. Number of trials is 3. Probability of success is 1 over 3. X value is 1, so less or equal, we need this value, less or equal 1. Go to here, we made mistake, so it should be 1 over 3. Okay, let's repeat. So second vars, I inserted wrongly, so cumulative distribution, trials 3, 1 divided by 3, so be attentive. X value 1, paste. Now everything is okay. Why it is B, some B's here? What is this B? Okay, again, second distribution, let's check what is wrong. Cumulative distribution, right, okay. 3, x value 1, paste. Now we got everything correct, but we need not this value, but 1 minus this value, so 1 minus answer, and we can convert it into fractional form by choosing 4. We get 7/27. So be very attentive when you insert data, don't make my mistakes. So probability of 2 or more red faces is 7/27. Then the next question is the most difficult. Ted plays the game using these dice. The rules are: having a turn means to roll all 3 dice. He wins $10 for each green face rolled and adds this to his winning. After a turn, Ted can either end game and keep his winning or have another turn. If 2 or more red faces are rolled in a turn, all winnings are lost and the game ends. Shows that after a turn the probability that Ted adds exactly $10 to his winning is 1/3. To get exactly $10 means that 1 green 0 red plus 1 green 1 red. 1 green 0 red means green and 2 yellow. So which combination it can have? Green yellow yellow, yellow green yellow, yellow yellow green, and all of them have the same probabilities. We add, we get 3 times 27. Probability of 1 green and 1 red is 3 different colors. 3 different colors is factorial of 3, or 3 times 2 times 1 equals 6, outcomes of 27 possible combinations. So its probability is 6/27. So adding these two probabilities, we get 1/3. So proved. Question is done. The random variable d represents how much is added to his winning after a turn. The following table shows the distribution for d, where w represents his winning in the game so far. Write down the value of x. So, probability of x, what is this event? When he loses and loses all money. So you see minus w, lost all money. If this happens when we have 2 or more red faces. So this probability we already calculated, it is 7/27. So we just copy this answer. All money are returned with probability 7/27. 2 or more red faces, it is answer of AII. Hence find the value of y. So here we have all outcomes. This is why total probability should be equal to 1. So total probability equals to 1. From this we get value of y equals 4/27. Ted will always have another turn if he expects an increase to his winning. Find the least value of w for which Ted should end the game instead of having another turn. Actually, they ask to find expected value when expected value equals 0. Expected value from 5/7 is given by value by probability. So we add unknown in w and we get w equals 34.3. If money is more than this value, then it is expected value is less than 0 and he should finish the game. As he is adding by $10, the sum should be $40. This is why we give answer $40. And here we finish the paper. Thank you for your attention.